Myself, Rajendra Aaseri. I am Assistant Professor in Computer Science Department at Government Bangalore PG College, Didwana. In the previous lecture series, we have discussed various concepts on cryptography and network security. We have discussed various aspects of cryptography. With the help of cryptographic technique, how we can ensure the security of the message. Then we have discussed some algorithm like RSA cryptographic algorithm, how to generate secret key in RSA cryptographic algorithm, how to perform encryption and decryption. All these concepts we have learned. Then we have learned various cryptographic technique like substitution and transposition type of technique, various type of ciphers like play-fade cipher, Hill cipher, Fistel structure, DES algorithm, triple DES algorithm, asymmetric and symmetric cryptographic algorithm, digital signature, importance of digital signature. All these concepts we have already discussed, right? Now in today's lecture series, we are going to discuss about electronic mail security. All of you know that in daily life we used to send at least 5 to 10 mail, right? In our professional life or in our personal life also we used to send some email. So how to ensure the security of the email means how to ensure that the email came from an authentic source, and how to ensure the delivery of the email to a legal recipient, a particular recipient. And in between, the mail should not be, content of the mail should not be, we can say, modify, or integrity of the electronic mail should be ensured, right? So all these things, to ensure these things, we require electronic mail security, email security. So in email security, there are various type of protocols are there, various type of algorithms are there. So we will learn step by step, right? So in this email security, we will be learning two protocol in detail. First is PGP protocol. It stands for Pretty Good Privacy, and second is S-MIME, Secure MIME. Secure MIME we will understand in the upcoming lecture. In today's lecture, our full focus will be on Pretty Good Privacy. Now before starting, I'm just summarizing I'm just giving an abstract about the PGP. So PGP is basically a protocol for to ensure the email security. It stands for Pretty Good Privacy. It perform the security in various certain steps. In some step we perform encryption, some step we perform compatibility of the content. So step by step compression also performed in PGP, so, right? So the order is very important, that in which step we need to perform encryption, which step we need to perform compression. So all these concepts we will be learning step by step. So starting with PGP. Now in PGP, one concept comes into picture, that is compression. Before going in technical detail, I'm just giving you a basic idea of the compression. Suppose in real life, I have a content of 5 MB, right? And I have to upload this, or I have the storage of only 4 MB. So 5 MB content and storage is of 4 MB. So I have to just reduce the size of our content. Now the problem is that when I will try to reduce the size of my content, the data loss might happen, right? So how to do, how to reduce the size without losing the data? So for that we can perform a technique that is called as compression. So with help of some software, with help of some application, we can just give as input our data, and in the output we will get the compressed data. So compressed data will be in the zip format, right? So now we are going in technical detail with respect to PGP. So in PGP, compression step plays a very important role. Why? See, PGP compresses the message after applying the signature but before the encryption, right? Very, so I'm just taking a marker. This is the compression step, clear. And suppose I'm saying this is encryption and this is digital signature. So if you read this point again, PGP compress the message after applying the signature. So first step will be, we need to apply the digital signature, after that compression will be done, and after that encryption will be done. Clear? The order is very important. DCE: first digital signature, second compression, and third is encryption. So the placement of compression is very important. Now one question comes into your mind, all the student, one question is coming in all of your minds, that why this order is this order is mandatory to follow, or we can change this order. Means compression can be done before digital signature, or encryption can be done before compression, or we can say encryption can be performed before digital signature. So can this order be changed or it is fixed? So this question, the answer of this question will be given in the upcoming slides, right? So why this, you will come to know after 2 or 3 minutes, right? So again back to the point. So PGP compress the message after applying the signature but before encryption, right? Now the placement of the compression algorithm is very critical, right? Means placement of the compression plays a vital role in PGP protocol. Now the compression algorithm used is ZIP. ZIP algorithm is used for compressing the message, right? Now next concept is email compatibility. Now suppose our email is in different format, right? So we need to apply some email compatibility techniques to ensure that it can be easily adjusted in the protocol, right? It is easily, we can say, compatible with the system, with the platform, with the algorithm, with the protocol, right? So the scheme used is radix 64 conversion. Means suppose our email is in different format, then we can apply a conversion technique called radix 64 R64 or radix 64 to convert our email in a compatible format. Now the how this radix 64 performed, see. The use of radix 64 expand the message by 33%. Suppose in our message there are 100 alphabet, so by after applying the radix 64 technique, the message will be having how many alphabet? 133 alphabet. It means it will expand the message by 33%. Means suppose our message input is there, we are applying what? R64. But by applying R64, the message will be having increased by, it will increase by 33%. Message will be increased by 33. So our input message we are giving to R64 technique, and it will give the output same message but by increasing the expanding the size by 33%, right? So if you see here, suppose our message is of 24 bits. So we divided our message in a 4 block, 24 bits. It means 6 bit, 6 bit, like 4 block. And after that we are applying R64 radix 64 technique we are applying. So when we apply radix 64, then 6 will be converted, 6 bit will be converted into 8 bit, right? So see, I'm taking a marker, 24 bit initially, it is 6 bit, 6 bit, 6 bit, 4 blocks we have divided our message in 4 block of 6 bit. 24 bit divided in 4 part, that is 6 bit in each part. Now after that, at every part we are applying R64. So 6 bit by applying R64 increased the size by 33%, it means it will convert 6 bit into 8 bit. Similarly, second, third one and fourth one. So initially 24 bit, now converted into 32 bit, right? So 32 bit is final expanded size. Clear? So it is, we are using what, printable encoding of binary data into radix 64 format, right? Now next step is very important, segmentation and reassembly. Segmentation means if our email is very large, then we cannot send our email at the same time concurrently. We need to divide our email in different part. Clear? In the different of which size? The size which is allowed at the same time to be sent. So segmentation often restricted to a maximum message length of 50,000 octet. Means we can, at a time we can send maximum length of the message is 50,000 octet. Means larger than that we cannot send at the same time. If it is larger than this, then we need to divide this. So longer messages must be broken into segment, right? So different part of the original message is called as segments, right? Now PGP automatically subdivide a message that is too large. PGP is having a property that if the message is larger than 50,000 octet, then it will automatically divide the message into different part. Clear? Subdivide a message that is too large, it will be automatically or implicitly divided by PGP protocol. Now, once it is divided, it will transmit it to the receiver. Now, once receiver got the segments, in order to understand the meaning of the message or in order to get the full message at the receiver end, one process needs to be done, that is reassembly. Means whatever we have done at sender end, that is segmentation, just reverse approach need to be done at receiver end, that is reassembly. So segmentation will be at the sender end. What we are doing? We are doing segmentation, and at the receiver end we are doing what? Reassembly. Reassembly we are doing, right? So dividing the message into different part, dividing the message, and here what we are doing? We are just adding again, right? So the receiver strip of all email header and reassemble the blocks. So receiver will again reassemble all the blocks. Clear? Now whatever we have done, just we are doing the summary. Now in PGP, various type of services are available. So I have listed all these services in a table. First function is digital signature. Clear? All of you know that digital signature is very important to, to reduce the non-repudiation type of attack. It ensures the integrity of the message, means it will restrict the modification of the message. It can be used in authentication also, to ensure the authentication also, right? So for digital signature implementation, we used DSS or SHA. SHA stand for secure hash algorithm, or DSS stand for digital signature standard. So for digital signature to implement, we use DSS, that is digital signature standard, or secure hash function, or RSA, that is Rivest Samir and Edelman algorithm, or SHA, secure hash function, right? For second service, that is message encryption, we used either cast or idea algorithm, or 3 key triple DES. In triple DES we are using 3 key, first for encryption, second for decryption, and third for again encryption. So with Diffie-Hellman or RSA for key generation, we for key generation, or we can say for secret key transmission or sharing of the secret key, we are using diffie element or RSA. Next service is compression. For compression, we already gone. The algorithm was zip algorithm. Email compatibility also we have gone. For email compatibility, we are using Radix 64 technique, right? And for segmentation, just automatically performed by PGP, no algorithm is required, and at the receiver end again automatically reassembly of the message will be done. So that's all from this particular lecture. In the next lecture we will focus on MIME protocol, how to use MIME protocol for implementing the email security. Clear? So before just concluding or just completing this lecture or finishing this lecture, just I am concluding again that for ensuring the email security, generally the best algorithm or best protocol is PGP protocol. In PGP protocol, various services are used like digital signature, message encryption, message compression, email compatibility, and segmentation. Clear? So we will focus on more detail in the upcoming lecture about PGP services. Thank you.